Greetings and welcome back to the lab. Today we have another kit to build, but this one is special. It's my first ever, the first one I've ever made, and I'm putting up for sale. So this will be the assembly video for this, and hopefully I won't have something to lampoon myself about in terms of instructions. This is my instructions, the video that I'm making for this. I can think back when I was a teenager many years ago, and there was a company that you could buy kits from. I don't want to specifically name, but they were well known in that field, and you'd get a catalog and you could open it up and thumb through and find the kit that you wanted to build and order it up, and it would come with a booklet of instructions and photos and diagrams, so you knew what you were working with, and you had good solid instructions, kind of, to the extent of put tab A in slot A, that kind of thing, and enough instructions to tell you about the components so that if you had to put them one particular way around because they were polarized, you couldn't get it backwards, or at least if you read the instructions, you couldn't get it backwards. So I just fondly remember that time, and I'm hoping I can kind of recreate it, because unfortunately that company has gone downhill. So hopefully I can start something here. Let's take a look at my first ever kit. This is what I've referred to as the flower. I can show you a little bit of B-roll here as I start pulling the parts out. It will come with a USB cable. Let me make sure I get that in frame. As I build this, though, I'm going to use another one for a test, but that will be the one that you will have. And we'll dump the rest of this out. And for this particular kit, there are 3 versions, actually. There is in terms of brightness, there's a low, a medium, and a high. This is going to be the medium that we're going to build. So here's the circuit board. In fact, let's start with the circuit board. And what I always do with my kits is I will lay out all the parts so I can make sure I have everything that I need. Now, there'll be a circuit board. There will be 8 resistors. Actually, I'm going to include more than 8 resistors just in case something goes wrong. That way you've got spare. We're going to need the actual LEDs for the flower. And there should be 8 of those. 7, 8, 9, 10. Once again, I'm giving you extras. I'm not sure if I'm going to put 9 or 10 in there. And we're going to need a header. This is this tiny little piece here. That I will explain when we get to it. And this is called a breakout board. And I'll explain that. And then we have some hardware, which, as of the building of this kit right now, is brass. But I will probably, since the circuit board is white, I will probably include white. And some screws that will go along with it. So that's all the parts that we need for this kit. That's all you need in terms of parts. What you're also going to need is a soldering iron and solder, and a pair of some kind of clippers. What I use are these clippers here. They are so I can, once I've installed the parts on the board, I can clip the excess parts off. And one thing that I do, because I build a lot of kits, is I have just a little container with all my extra pieces. And what else? I think that's it. I do want to show you on the solder. You got to be careful. You got to make sure you get the actual tin lead solder. Well, you don't have to. My preference is the tin lead solder. There's a lot of lead-free solder for reduction of hazardous substances, because lead is seen as a bad thing, but in the quantity that it is, building a kit, it's not that much. So I prefer the old-fashioned tin lead copper solder. if you buy a kit, and I will include links on the website and in the video for the soldering station that I have, as well as some suggestions for solder. But all right, let's jump right into this thing. First step, I'm going to move some things out of the way here. So I have a work surface. The first step is going to be to put the actual resistors into the circuit board. Now, I'm going to pull out all but 2 of them here because I have some confidence in my own ability. But if I screw up, I'll have extras to go back to. We're going to need 8 of them. That's why I'm just carefully pulling them out here. Now, I tend to try and pull them all out as a unit so that they'll all be pointed in the same direction. This is not necessary. I just had one fly away, didn't I? Yep. There we go. It's not absolutely necessary to have them pointing in the same direction. With resistors, it doesn't matter which direction you put them around, but we do want to put them in. If you put them in one at a time, that will probably be the easiest for a very beginner. But I'm going to put in 4 at a time because I'm going to have to navigate around all of the leads that'll be sticking out the back. That's why basically one at a time, you're going to put it in, you're going to turn it over, you're going to solder it on, and then you're going to flip it over again and clip the leads. Sorry, no, I'm saying that wrong. You're going to put it in, you're going to flip it over, you're going to solder it, you're going to clip the leads, then you're going to flip it over again and put another resistor in. So there's a lot of flipping involved. In my case, if I do 4 at a time, since there are 8, I've basically got half of them. I only have to do this twice. So whatever you're comfortable with, you can try 1 at a time. If that gets too tedious, you can go to 2. And then when you build up your confidence building kits, you can do more than 1. Also, I start with the lowest profile components first when I build a kit, because once you put the larger components onto the board, it's harder to get the smaller ones soldered in. So there's that. Now let's solder these components on. Get the joint first, hit it with solder. And that's got 4 of them put together. Now I'm going to go back and clip the excess leads. You might want to hold the end of the lead before you clip it, otherwise it may ping across the room and you'll be wondering for days where it went until you step on it. I have a dedicated area for working on this. You might want to work at a dining room table, kitchen table, some place where you can clearly see what you're working on. And where if something does go pinging across the room, you can find it. Once you gain a little experience, then you can do it pretty much anywhere. All right. Let's put another 4. Now, I literally started with R1. There is printing on this circuit board to help guide you. So this is R5 I'm working on right now. R6, R7, and so on. And there are also associated LEDs with each one of these. Whoops. Something happened. It looks like a couple of my leads got loose on me here. Let me move them up off the board. Oh, this is a magnetic board here that I'm using to protect the table and build my kits on. They make bigger ones than I have here. And there are also a lot of people that use a blue mat which is a heat-resistant rubberized mat, which has little compartments on the sides. If you were taking something apart, you would have a place to put all the screws and such. Just don't have that. This is what I have, and this is what I use, and it works out fine for me. Okay. I was trying to make the resistors look a little bit more consistent, but in the end, it's not going to be as noticeable. So, flip it over here. Let's do a little bit more soldering. That's a problem. Somehow I managed to stick the leads for 2 resistors through the same hole. That would explain why I had a bit of a problem. Why this one went wonky on me. Good thing I caught it. There we go. Now, if you want to keep them from falling out on you while you're flipping it over, you can actually spread the leads a little bit further apart, and it should hold at least for a little bit. But I've gotten a little bit used to doing this, so it's not as much of a problem. Glad I caught that before. Otherwise, I would have soldered 2 leads into the same hole, and that part of the circuit wouldn't have worked. So watch out for that. Now, I'm going to go back around, double check all my solder joints. Make sure they have enough juicy solder on them. You don't want too much, but you want to make sure that you've done a complete job. Okay, that looks good to me. Let's snip the leads. I built another one of these last night without the commentary, just to see, and it took me about a half hour to build the entire thing. It may take, if this is your first kit, it may take you a little bit longer. If you have to, give yourself a couple of sessions working on it. It's better to be slow and methodical rather than making mistakes. And if you do make mistakes, there'll be a comment section on the website with this video, so there's an opportunity for you to ask questions. But there we go. Now we've got 8 resistors. Now we're going to install the LEDs, and these are polarized. It does matter what direction you put them around. So if you look carefully, you will see that for each one of these LED symbols, there's a flat side. That flat side represents negative. There's a positive and a negative to each one of these LEDs. If you were to look really carefully at the LED itself, on the cap here, there's a flat side. It's really hard to see with clear LEDs unless you get them really up close to your eyes and take a look. But what I also know about LEDs is that there is a long and a short leg, okay? The short leg is actually the negative. The short leg is the one that's going to go right up against that flat side. So if I just make sure to always put them in that direction, I'll be okay. Now, I'm not going to solder them right away because I want to show you something. But I want to put a few of these in. Maybe I won't go to 4 right away. We'll do 3 at a time this time. Now, I haven't actually soldered them in because what I actually want to do is lift them back out part way, just a little bit, just about that much, and then bend it so it's sticking out the side. The whole idea with the flower is that these LEDs are like petals, and the light is emanating out the top of the LED, so we want to push it over to the side. Now, okay, I've bent that one a little bit too much, so I'm going to drop it back down a little and bend it again. And you can see now the leads are sticking out. I'm just going to push them back a bit. And that's what I'm going to end up doing for all of these. It's not absolutely critical how far they go, although it'd be better if they're consistent. So that's those three. And the more I look at it, that was fun trying to turn it over without losing that. This one I need to rebend just a hair. Oh, that one's going to be a bit more fun, isn't it? All right, I have an idea how I'm going to solve that problem. All right, that's those two. Now I got to flip that in there a little bit. There we go. So it'll sit down almost flat. It's a good thing I'm having slight problems as I do this, so you can see the things you might encounter. You build enough of these, it starts to go much smoother. That's why I'm able to build them generally in about a half hour. All right, now BigClive.com has his suggestion. He's a great channel I really like. And his suggestion is always to do one side of the LED first so you don't burn up. There's a circuit inside this little clear cover. It's so microscopic you're not going to see it. But if you do one leg at a time, then you give it a chance to cool down when you come back to do the other leg. Now we're going to cut off the excess leads. Try and hold on to them so they don't... Well, there you go. That one just pinged. I saw where it landed, so I'm good. Yeah, it occurs to me, this is kind of like a needle. You could almost build one of those compasses where you take the lead. This is a magnetic mat. And I could magnetize the lead, get a cork, put the needle on top of the cork, and build a compass with it. So there you go. You have another kit you could build with just the spare parts. All right, that's 3. Let's go for the other 5, and we're just going to fast forward through this. Okay, I'm going to pause here as I'm cutting off the leads to say you probably saw me there where one of them actually fell out while I was flipping it over. If you have a problem with that happening and you have some tape lying around, something like this, okay, I have some electrical tape. It doesn't have to be electrical tape in this case, but if you have tape lying around, you get a piece of it, and hopefully this is not the first. Hopefully you're watching this video before you build. But I'm going to cut off a piece here because this might help with all the other parts, like with the resistors. You literally, once you put the parts in, you can put a piece of tape over against the circuit board, and that'll hold them in while you're flipping it over. So that's just a thought. Hopefully that helps somebody. All right. We're in the home stretch. If you look at how many parts we put on versus how many parts are left, we're almost done, especially almost done with the actual soldering. Now, this header is the next piece that's going to go on. The idea here is that this is a micro USB breakout board so that I can use a USB lead to power this entire project. There is on the back side of this circuit board, you may have noticed there's some text. This is actually the website. But right here is where I'm going to put the header, and there is a small plus and a minus here. Now with the header, it doesn't matter just yet, but I'm going to stick the header in with the long pins going through the board. We should line right up. Now, this would be the only thing I'm soldering on the front of the board. That way I keep it from becoming kind of messy. Ooh, wow, one of my LEDs is really wonky. I'm going to have to go back and fix that. All right, but I'm going to go ahead and solder this on now. You really only need the 2 outside pins. The rest of them are there for support. But if you want, and I'm going to go ahead, I'm going to solder on all 5 pins because it's going to make it that much more stable sitting on here. Now, this is some fine soldering, so don't worry too much about the middle pins, but if you're feeling up to it, go for it, and it'll be that much more solid. Now, this is the breakout board, and on this board is printed in really tiny lettering, ground on one side and V-bus on the other. Really, ground is minus and V-bus is plus. It should go in the same orientation with the actual connector on the top. As you lay it down on top of the header, okay, I got to put on the old man glasses. Sorry, if you've seen me struggling, that's why. Should have thought of that before I started. It makes it a little easier for me to see what I'm doing. Now, I got that over by 1. That's something I hadn't considered in the design. Oh well. There we go. I got it lined up. Now, what I'm going to do is actually only solder on one of these first, because I want to be able to straighten this thing out after I've soldered it on. But I want it to actually be mechanically bonded there. Now, the problem is, now that I've soldered that, if you look at it, it's crooked. It's not straight. What I can do is I can lift up the far end with my finger while I heat up that solder joint again, and I can get it straight. Once I got it straight, I'll need to go a little bit more. Now, be careful. If you solder the ground first and then do this, the heat may transfer through to that actual connector. That's pretty good. So now I'm going to go ahead and solder the rest of the pins. Now, I can do just the 2 outside ones, because this is USB, but it's only being used for power. The other pins are actually for data, which is why you can use USB to connect things on your computer. I'm going to go ahead and solder the rest of the pins. Now, the thing you got to be careful about is if you use your computer to power this and you accidentally solder these wires together, then you might have a problem. So I highly recommend that when you go to turn this thing on for the first time, you use a power bank. Something like this or that. These are just examples. There are all sorts of different types of power banks. I also happen to have an old phone charger plugged in with a lead. So I'm going to put these aside, and we're going to plug it in. I'm going to see how it works. The back side here is actually the flat side of the connector. Let's get that in. There we go. We are lit up at medium brightness, and you'll see they're all in unison right now. And if I just let this sit for a minute, you'll see that it eventually start to go out of sync. There, it's starting. You can see one color leads another. And if you let it go long enough, it's still doing the same sequence of colors for each LED, but they're all out of sync to the point where it's kind of hard to tell how far behind one is from another. And that contributes to the randomness of this. Now, I'm actually blocking one of them with the lead, but when you put this in whatever device, whatever configuration you're going to put it in, I literally call it a wallflower because you can mount it to the wall. And to do that, I'm using, see now my lead is a little bit stiff here, so it wants to bounce around. I use this middle hole. That's what that is there for. This middle hole was drilled in the board, so if you did a more complicated project to use this as part of it, you can run wires through there, or you can put a screw in the wall, or like a small nail in the wall and hang it. Or if you're feeling up to it, you can actually put a screw through here into the wall, and let's actually turn it off. So now you get an idea how that's varying a little bit. I'm going to unplug it. That's what the hardware is here for. The hardware will sit on the back of the board against these other holes and allow it to stand proud of the wall. If you imagine the table here is actually a wall, it's going to sit up from the wall a little bit. That allows enough room for this connector, and by putting 4 of these standoffs, actually on the other side of the board, but by putting 4 of them, you end up with an even spacing. So that if you do screw it to the wall, it's actually these that are contacting the wall, not the circuitry. So I need to fix that one LED. Where did it go? Yeah, you see this one is just kind of went wonky on me. So sorry, it's this one here. So what I'm actually going to do, oh, that's in perfect location there, isn't it? All right. I would have to remove this board in order to heat these joints up, or I'd have to be very careful about putting my soldering iron right into the middle there and then using my finger to push the entire LED in. Now let me give that a shot, but it's going to get, these wires are going to get hot. Ow. There we go. That's a little bit better. Now, I don't have to cut the leads because they're not actually touching. And I think I'm okay. But let's see if we can't get the clippers in there. There we go. That's a little bit better. Now, that's not perfectly level, but what I can also do is just bend it. You can bend these leads after you build it so you can straighten things out and make it nice and even. I like putting it against the table and then just pushing down against each one of these LEDs. They're all pointing in the same direction, or they're all on the same plane. That's what I like to do. So that gives me a reasonably even distribution. When I put it against the wall, you saw when I had this. Now let's plug it in again. Let's look at why I call it the flower. Oops, wrong direction. You see how they're each pointing out in that direction? Those are the petals of the flower. And yeah, I'm swamping out the camera a little bit while I do that. But that's why I call it the flower. And actually, if you turn off the lights, it'll project out a bit further. And the difference between the low, the medium, and the high, besides just simply the brightness of this, is how far this projects out. So I will give you a view as we close out the video of the low, the medium, and the high together, so you have an idea. But we have one more thing to do. What I tend to do is grab the screw and put that in first. Oh yeah, you're going to need a screwdriver. So there's 2 holes in between 2 LEDs on 4 sides, so you can do 4 of these. If you wanted to, you could do only 3. I would recommend the 4. But also these holes are matched so that if you take the first one here and the first one there, they're 90 degrees apart. So you'll get perfect distribution of the weight when you screw it down, if you screw it to the wall. Well, here we go. All right, I got it started. It's easier to get it started that way and then screw it on like so. So now I have something that sits off of the table, and if this was the wall, sits off of the wall. The LEDs themselves, before I put that on, I got them to kind of be in the same plane. running across the same plane. But what I didn't do was adjust them so that, now you can do this even once you've mounted it to the wall, you can fine tune these just a little bit. Again, you can bend the leads, but you don't want to bend them too much, otherwise they might just snap off. But if that happens, you got spare parts that I included with the kit. It does mean that you have to unsolder the LED to put a new one on. But anyway, what I want to do is I want to try and make sure that they're all, see, like this one, I can tell these two are not pointing directly opposite one another. This one could be bent that way a little bit. That'll help. Then I can go look at all, yeah, I can see this one needs to come out that way a little. And yeah, I think both of them need to be brought in a little. So you get the idea. I could sit and adjust this forever. No flower is perfectly symmetrical, so don't worry about making these perfectly symmetrical. I'm flipping it over here because after I bend that, it's probably changed these. So I'm going to hold down the center, and I'm going to push. Now this does, when you do it this way, will make it so they project out further, but the projections won't be as closely tied to the middle of the flower. But there you go. That is put together. We'll light it up one more time, and we'll let it run for a bit so you can see, and then we'll finish out the video. With that, I'm going to stop talking and just let you watch. Enjoy.